Hello students, welcome to Vidya for Success. In today's session, let us study how to solve problems on hypergeometric distribution. Here is a question. A basket has 10 mangoes, out of which 6 are ripe. 3 mangoes are randomly selected. Find the expected number of ripe mangoes among the picked ones. Second question, the probability that all the picked mangoes are ripe. Please notice here, the question says that there is a basket having how many mangoes? Totally there are 10 mangoes. How many mangoes? There are totally 10 mangoes. Out of these 10 mangoes, 6 of them are ripe. So, out of these mangoes, 10 mangoes, 6 of them are ripe. Nothing but there is a particular characteristic on which we have divided the entire population into 2 categories. What is that characteristic? Mango, whether it is ripe or not. So, one group for the first category is number of mangoes which are ripe. Another category is number of mangoes which are not ripe. Okay. So, the complete population is split into 2 categories, 2 groups. So, there are 6 mangoes which are ripe and similarly 4 mangoes which are not ripe. So, 6 plus 4 will make the total number of mangoes in the basket, that is 10. Next, from this population we are drawing a sample. Okay, we are drawing a sample. In the sample, how many mangoes will be there? We will be drawing a sample having 3 mangoes. Okay, so out of these 10 mangoes, we will be picking any 3 mangoes. So, let us write down what are the given data in the question. So, solution. So, given that, what is given from this question? Given that we know what is the population size. The population size is 10 mangoes. But we don't want that population size. We need to know what is the number of units or elements present in the first category having a particular characteristic. So, they have given us that out of 10 mangoes, 6 of them have ripened. So, nothing but A is equivalent to 6. If A is equivalent to 6, then what is B? B is equivalent to 10 minus 6 here, that is 4. B is equivalent to 4. Followed by that, we also know that from the population of 10 mangoes in a basket, we will be picking for a sample. What is the sample size? And the sample size is n is equivalent to 3. We will be picking only 3 mangoes. This is the given data. Next, for this particular given data, let us consider a random variable x. So, what is x here? X is a random variable. What does x indicates here? X indicates number of what? Number of mangoes, correct? X indicates number of mangoes. Which particular mango? There are 2 categories of mangoes. One is ripen, another one is not ripen. So, here x indicates number of ripened mangoes. Mangoes which are ripe in a sample of 3 mangoes. Okay, I hope you are understanding. So, the complete sample again what we have drawn from the population of 10 mangoes, they may have 1 ripe mango or 2 not ripe mangoes. Similarly, they may also go with another combination of all the 3 ripened mangoes without any non-ripened mangoes. It can also be the scenario. So, here what does x indicates? X indicates number of mangoes which are ready to eat, that is ripened mangoes. So, x indicates number of ripe mangoes. Okay. From how many we are selecting? There are only 3 mangoes in the sample. Among those 3 mangoes, how many of them are ripened? So, x indicates number of ripe mangoes among or else in the sample of 3 mangoes, in the sample of 3 mangoes, or else you can just write in the sample, that's also enough. Okay, but for your information, in the sample, to know how many mangoes are there, here I have written. Okay, so first, after writing what is the given data, we have also defined what is the random variable. So what is x? X is number of ripe mangoes in the sample of 3 mangoes. Now let us write the probability mass function. The probability mass function P of x is equivalent to, here we know what A, first category, we know second category, and also we know the sample size. So this problem comes under hypergeometric distribution. So what is the probability mass for hypergeometric distribution? P of x is equivalent to ACx followed by BCn minus x divided by A plus BCn. This is the probability mass function. So here where x can take value 0, 1, 2, dash, minimum, what will be the minimum value it can take? X, it can take A comma n. A is number of elements or units possessing a particular characteristic in the population. And what is n? N indicates the size of the sample. Okay. So this is the general form. This is the general form. Then what about the customized version for our problem? So P of x is equal to ACx. What is the A value? 6. Cx. B value is 4. C n minus x. N is 3. 3 minus x divided by A plus B, that is 6 plus 4 is 10. 10 C n value size of the sample is 3. Where what will be this x value? Where x is equal to, it can take 1, it can take 2, it can take 3, dash, minimum. What is that minimum value the x can have? What is the number of units possessing a particular characteristic in the population? There are 6 units or 6 mangoes which are ripe. Among what is the size of the sample? The size of the sample is 3. Okay, so nothing but in a basket there are 10 mangoes, out of which only 6 mangoes are ripe. So we are drawing a sample of size only 3, nothing but there will be only 3 mangoes will be there. So there will be only 3 mangoes. So what is the x value now? The x value can be 0, 1, 2. It can go up till minimum it can have 3. What is the proper characteristic of the units possessing a particular characteristic? That is 6. So nothing but here x can take value 0, 1, 2, 3. It cannot go beyond 3 because sample can have only 3 mangoes. Even if there are 6 mangoes which are ripened in the basket, for a sample we can consider only 3 mangoes. So what can be the x value in the sample? In the sample there can be no mangoes which are ripened. There can be only 1 ripened mango, there can be 2 ripened mango, or else there can be all the 3 ripened mangoes in the sample. This is what this indicates. This is very, very important. You need to understand this. So now we have customized the PMF for a problem. So let us solve the first question. What is the first question? Find the expected number of ripened mangoes. We need to find the expected number. What does it mean expected? If you have studied the first year chapter, that is expectation chapter, expectation of a random variable, expectation is nothing but mean. Okay, so the first question we need to find the solution for the first question. We need to find the expected number of ripe mangoes among the picked ones. From the basket we will be picking a mango. what is the expectation that particular mango will be ripen? We need to find that. Okay, so nothing but we need to find expectation here. This is very, very important. You need to understand this particular terminology. We need to find the expected number. It is an average, nothing but mean here in hypergeometry. So what is the mean? Expectation of x is nothing but mean of the hypergeometric distribution. What is the mean of hypergeometric distribution? N into A divided by A plus B. That is, what is the sample size n value? N value is 3 into what is the A value? A value is 6. Again, A value is 6 plus 4, that is 10. So, 6 3s are 18, 18 divided by 10. So, 18 divided by 10 is 1.8 is the expectation that if I take out a mango from the basket, that will be a ripened one. Okay, so that is the expectation. So we have solved the first question. Now let us take up the second question. What is the second question? Find the probability that all the picked mangoes are ripened. Okay, so from the basket we will be picking only 3 mangoes into the sample. What is the probability that all the picked mangoes, all the drawn mangoes from the sample without replacement are ripened? So, probability we need to find that all the mangoes are ripened. Probability that all the picked mangoes are ripen or ripe, I can consider. That is probability of x is equivalent to, what will be the value of x? X is equivalent to 3, correct? In the sample, how many mangoes are there? Only 3 mangoes. So, what is the second question? We need to find what is the chance that all the 3 picked mangoes are ripened. Okay, so that is probability of x is equal to 3. Let us now write down, work with the PMF. Once again I will be writing the general form ACX BCN minus x divided by A plus BCN. Okay, so now let us replace A value with 6. 6 CX 3 followed by B value is 4. 4C N value is N value is 3. 3 minus 3 is 0 divided by A value is 6, B value is 4, 6 plus 4 is 10, 10C3. Okay, so what is this is 6C3, that is nothing but NCR. Okay, NCR is equivalent to n factorial divided by n minus r factorial into r factorial. So you need to use this particular formula. Okay, so what is 6C3? So 6C3 is equal to 6 into 6 factorial. 6 factorial is 6 into 5 into 4 into 3 into 2 into 1 divided by n minus r. 6 minus 3 is 3. So 3 factorial is 3 into 2 into 1. Again 3 factorial is 3 into 2 into 1. So here 3 into 2 into 1, here 3 into 2 gets cancelled. 3 1s are, 3 2s are 6, 2 1s are, 2 1s are here. So 5 4s are 20. So 6C3 is 20. Okay. So let me replace 6C3 with the value 20. Let me write it down here. So the first 6C3 is 20 into what is 4C0? 4C0 is nothing but 1. Okay, 4C0 is 1 followed by again 10C3. So 10C3 is 10 into 9 into 8 into 6, 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 10 minus 3 is 7, 7 into 6 into 5 into 4 into 3 into, so it goes on 3 into 2 into 1, again into what is the 3 factorial, 3 into 2 into 1. So here 7 into 7 gets cancelled, 3 ones are, 3 threes are 9, 2 ones are, 2 fours are 8. So 10 threes are 30, 3 fours are 12, 120. So 20 by 120, that is 1 by 6. 20 ones are 20, 6 are 120. So the answer is 1 by 6. Okay, the answer is 1 by 6 for the second question. That is the chance, the probability that all the picked mangoes are ripen is 1 by 6.